All right, today what we're going to talk about is direct, joint, and inverse variation. So let's get started with some vocab and examples first. So first off, we have direct variation. Now you've actually learned about this before, and the formula is y equals kx. So this one is more of a linear, so it's a constant rate, and the reason it's a constant rate is because it's directly proportional to x. So basically, as one increases, the other increases. Or if one decreases, the other decreases. So they're both, and I have some examples on the bottom. If you study, the more you study, the greater your grades go, or the less you study, the lower your grades are. So they're both either positive or they're both negative in that respect. Then you have joint variation. So this varies jointly with x and y. So z varies with two or more different quantities. So it varies directly. So it's very similar to the direct, but in this instance, you actually have two or more different things. In this case, you have x and y. So an example would be a number of gallons in a pool varies jointly with the square of the pool's radius and the depth. So you have your radius and your depth are two different things. That could be your x and your y. And then inverse, y varies inversely with x, so it's inversely proportional. So this graph is going to look different. Direct was a straight line, but inverse means it's going to curve like that. So this one is different because as one increases, the other decreases. So as your speed increases, the shorter the trip is, or vice versa, if you were to one increases, the other decreases, or one could decrease and the other increases. All right, so let's go ahead and let's get started here. We want to translate each statement into a formula. We're going to use k as the constant of variation. That's pretty typical with this. So the first one I did with you. So I said v varies jointly as b and h. So what we're going to do is go up here, use the formula for jointly, and we have v varies, so that's your equal sign, jointly. So that tells you so here's your k statement, constant of variation, times b and h. So that's pretty easy. Just go ahead and do that one. Now for number 2, p varies directly, so I'm looking at this one, as the square of v, so square of v, and inversely as r. So that and is where you put your division sign, and then you put your r here. And don't forget your constant of variation is k. So you've got y equals kx. So think of this as your y equals kx. And then and inversely as r. So inversely would be the r right here. All right. So what I want you to do is I want you to try those two. And like I said, look for your keyword. So here is actually a twofer. I didn't highlight this other part, but let me highlight that real quick. So that would be the bottom part there. All right. Now let's go ahead and we're going to do this bottom here. And it says solve for the indicated variable. Always solve for k first. So we're always going to look for k first. So it says find y when x equals -6 if, and that's important, y varies directly as x and y equal 8 when x equals 2. So that's kind of, you need to think about what it's actually saying. So first we need to figure out the varies directly, which is your y equals kx. So we're going to find k first. So to do that, let's write our y equals kx. And we know that as x and y, 8 is right here, that's your y. And then x we said is 2, and that's your 2. So we're solving for k, divide both sides by 2, k equals 4. Now that we know what k is, now we're going to plug it in, and it wants to know when x equals -6. So that's why we're plugging this into our formula now. Now that we have k, so now we just go y equals 4 times -6, and that's your answer. So remember, take the information here to find k, and then once you have k, then it's saying to find here, plug it in. All right, So let's go ahead and say find y when x is 3. So this is what we're going to solve for later. But to find that, we have to first do y varies inversely as x. So inversely is here as x when x equals 4 and y equals 16. So that's all we're doing, and then multiply both sides by 4. You get 64 equals k. Now that we know what k represents, now we're going to substitute that into your y equals kx. Oops, I hit the... There we go. So this is that. You can just leave it at 64 over 3. That's fine. All right. I gave you a hint on this one. For number 7, it varies jointly. So I want you to try that. Here's your formula. Remember to find k first. And then on this one, I'll give you a hint. Make x equal 3 halves. That'll make it a little bit easier when you're doing this. But you're going to find y when x equals 1.5 or 3 halves. If it varies directly, so you're going to use this first with this and this. Once you got k, then plug it into the other. So go ahead, try those. And then now you have variation word problems. So these are kind of the same idea, but it kind of gives you more of the relationship between the two. So the price of the diamond is directly proportional. So directly would be y equals kx, but we're going to go to the square of the weight. So don't forget that there. So if a 1 carat diamond costs 2,000 pounds or $2,000, find the price of a 0.7 carat diamond. So first we need to figure out what k is. So we're going to put p, I said was the price. So we said the price is 2,000 and a 1 carat, which is 1 carat here, and then you square that and you get k equals 2,000. But we're not done because that was for 1 carat. We want to know if it's a 0.7 carat. So now substituting your value for k, so this is your k, this is your weight squared, and you're going to figure out what the price is. And then go ahead and multiply those together and you get $980. Now this one for 11, when air is pumped into the tire, the pressure varies inversely as the volume, I didn't highlight all of that, sorry, as the volume of the air. So let me just erase that and fix that real quick. Inversely, since I didn't get it all, there it goes. Okay, as the volume of the air, if the pressure is 30 pounds per square inch and the volume is 140 inches, find the pressure when the volume is 100 cubic inches. So now we need to figure out what is the original, what's the k value. So we're going to go ahead, it says the pressure is 30 per square inch when the volume is 140. So we're using those to find k. Once we've got k, now that we've got k, we're going to plug it in for when it is 100. And go ahead, and then that would be 42. All right. So what you're going to do is you're going to go back, you're going to complete all of these, use the little formulas we have from before, but remember, solve for k first. Then once you know what k is, then you can plug it into the actual equation that it's looking for. Oops. And then that is direct, joint, and inverse variation.